Hi, welcome to my video on extra problems number 6. Number 1, a rhombus DEFH, which has DH as x and the angle DHF is 2 theta. Show that the area of the rhombus is 2x squared sine theta cos theta. Well, to do this, I need to draw a rhombus. The rhombus is D, E, F, H, and DH is X, and the angle DHF is 2 theta. So we need to show that the area of this rhombus is 2x squared sine theta cos theta. Well, we have a rhombus, and a rhombus is a quadrilateral with all sides equal. So that means this side is x, this side is x, and this side is x. And a rhombus, what I'm going to do now is draw this diagonal down here. And I'm going to get the area of one of the triangles. And these two triangles are congruent. These triangles are congruent because if angle H is equal to angle E, opposite angles of a rhombus are equal, and all the sides are equal. So these two triangles, DHF and DEF, are congruent by SAS. So the triangles are congruent. So let's get the area of the triangle DHF. And the area of a triangle is half of AB sine C. So in this triangle, A is X, B is X, and the angle C is H. So that's the sine of 2 theta. So we have a half. X times X is X squared. And the sine of 2 theta is 2 sine theta cos theta. And a half times 2 is 1. So we got X squared is sine theta cos theta. So that's one triangle. But the area of the rhombus, I'm going to call it RHOM, is the area of the triangle DHF plus the area of DEF, and the two triangles are congruent, so it's X squared sine theta cos theta. Add on, same term again because the two areas are equal, and when we add them together we get 2x squared sine theta cos theta, which is what we have to prove or show. I could have said I could have doubled this triangle in area and put a 2 here and 2 times this if I wanted to. Now we want to look at this diagram, and we want to show that based on this information, that show that the tan of 2 alpha is 2ab b squared minus a squared. Well, we have to get the y has to go, so this is a right triangle with a right angle. So the hypotenuse squared, which is the square root of a squared plus b squared, the hypotenuse squared is the square of the two sides, which is y squared plus b squared. That's the Pythagorean property. And the square root of a squared plus b squared is a squared plus b squared, y squared plus b squared. The b squareds cancel out, so a squared is equal to y squared. So y is equal to plus or minus the square root of a squared. Y is plus or minus a, and the length of the side can't be negative, so a has to be positive. It can't be negative. Now we have to look at the tan of 2 theta. And the tan of 2 theta is, the tan of 2 alpha, sorry, is 2 tan alpha and 1 minus tan squared alpha. And the tan, in terms of alpha, the tan of alpha is the y over the b, and the y is a over b. So tan is opposite over adjacent, which is the y over b, but y is equal to a. So the tan of alpha is a over b. So let's sub that in. The tan of alpha is a over b. And tan squared is a over b squared. So let's simplify that. So 2 times a over b is 2a over b. 1 minus a over b squared is a squared over b squared. And we have, notice we have a complex fraction. So the LCD for this complex fraction is b squared. The common denominator for the numerator, the denominator for the numerator is b. The denominator for this bottom part here, this part is b squared. So the common denominator for both the numerator, which is this fraction, and the denominator, which is this fraction, is b squared. So I'll multiply the top and the bottom by b squared. So b squared times 2a over b, b squared, the b's cancel, and I get 2ab. And I multiply this one by b squared, and I multiply this fraction by b squared. So b squared times 1 is b squared, and a squared over b squared multiplied by b squareds cancel, and I get a squared, which is what we have to show. And again, it's just a little different proof. Wanted to use tan 2 theta, and we've accomplished that. And again, this one had to use the sine of 2 theta, double angle formula, and this is the double angle formula for tan. This brings us to an end. And again, if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, videos, and the content. And that's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.